This is taking these methods and then trying to dive deep into one particular area to understand what these methods can tell us about the underlying processes. And then I put the names of the people that I did this with just to embarrass people. So Christopher Eicher was a BS, MS in Applied Math from Colorado. Abigail Jacobs, Abby's in the audience here. She's a PhD student of mine. Lito is one of my postdocs. Dan's another one of my postdocs. There's Abby again. And Caroline Buckey is my malaria collaborator at Harvard. OK. Also, to embarrass them, I put their faces up here. All right, so the first application is to edge-weighted networks. How can we take this basic structure of thinking about coarse graining the network, coloring the vertices to figure out which vertices are stochastically equivalent to each other? We want to generalize that to the application in which we have edge weights on the network. It turns out that edge weights are really, really common. It's really hard to think of a network in which an edge isn't really actually weighted in some way. So the weights can represent the frequency of interaction, the character, the duration, the outcome, the capacity. All of these things are really weights. And often when we have a network, we've thrown out that information somehow. We've perhaps either thresholded it by saying that there's some threshold that I choose, and if the weight is above that, then I say the edge is there, and if it's below that, I say it doesn't count for some reason. In fact, this turns up in experimental data too. When I'm measuring the strength of the interaction between a pair of proteins, I want that interaction to be strong, but there's some sort of baseline noise. And sometimes that noise is hiding some signal, and sometimes it's not. So usually what I do is I throw out everything that I think could be noise. And it's not clear that that's the right thing to do. So this is the approach that we often take, that we apply this threshold to the weights and then use unweighted network methods on them. So here's a parable to convince you that that's not a good thing to do. I borrowed this phrase, valued ties tell fewer lies, from this excellent paper down here from a couple years ago. But so here's a really simple network that I cooked up, or rather that Chris cooked up for me. So we have 4 groups.